So in this video, we are representing the rough endoplasmic reticulum in a eukaryotic cell, and also the protein SEC61-alpha-1. We chose to use many craft materials because they're creative and easy to make into different organelles. Our approach is unique because we use craft objects as a fun visual representation of the cell and its many components. Using both biology and creativity helped us to more fully grasp how the rough ER of a cell functions and the overall makeup of a eukaryotic cell. Biology and creativity were also equally emphasized because we were not only telling facts about the cell and rough ER function, but also visually representing it in a creative manner using many different objects.
Yeah. This is our eukaryotic cell. This is the nucleus. This is the smooth ER, the cytoskeleton, the lysosomes, the mitochondria, and the Golgi apparatus. We are doing the rough endoplasmic reticulum. The yellow dots are the ribosomes. The ribosomes are bound to the cytosolic base of the rough ER or free in the cytosol. The rough ER is where protein synthesis occurs. The rough ER is bound by a single cell membrane. It includes the majority of the ER membrane, and if the proteins do not stay in the membrane, they are sent to the Golgi apparatus.
This is the phospholipid bilayer, specifically in the endoplasmic reticulum. We have the phospholipid head and the tail. The head is hydrophilic, while the tail is hydrophobic. This is why the tails face inward, because they're hydrophobic, and hydrophobic means that they do not like water. And this is why the heads are facing outwards, towards the water or towards the other solution, because they don't mind the water. Then we have a channel, which you will see later will help move proteins through the membrane.
This is the zoomed in membrane around the rough ER. Our protein was SEC61-alpha-1. This protein plays a major role in the insertion of secretory and membrane polypeptides into the ER. It is a subunit of a channel that the ribosome and the rough ER attaches to, as shown here. This allows proteins to either be secreted or to stay in the rough ER as a transmembrane or integral protein.
A point mutation in the SEC61-alpha-1 leads to diabetes and increased buildup of fat in the liver. There is a histine to tyrosine substitution at amino acid 344. This gives stress to the endoplasmic reticulum. It mainly affects mice. Yes, mice can develop diabetes. It is not only in humans. All mammals produce insulin because all mammals have a pancreas. Just a short lesson on diabetes. There's type 1 and type 2. Type 1 starts as a child and is usually called juvenile diabetes. This is when a child does not produce enough insulin. Type 2 diabetes, which is the most common, is when blood sugar levels are higher than usual.